We're going to start section 5.1. We're talking about the natural logarithm, or ln, and differentiating that function. So lots of this stuff that's in view right now is review from Algebra 2 or Pre-Cal. In fact, everything is review except for this part right here. All right, we talked about in the previous video that the derivative of natural log of x is equal to 1 over x. And from here we can take the second derivative and we could show using the power rule that the second derivative of natural log of x is negative 1 over x squared. Alright, so we can see a few things from that. We know that from Pre-Cal that the natural log has a domain from 0 to infinity. The range is from negative infinity to positive infinity. It's always it's continuous and always increasing, so it's 1 to 1, and it's always concave down, has that shape. In Pre-Cal we didn't really have a word for that shape, but now we know that it's concave down, and we can see why it's both increasing and concave down when we look at the first and second derivatives. If we put any x value within the domain of ln of x into 1 over x, we're going to get a positive value. So that means that the first derivative is always positive, therefore the function is always increasing. And if we put any value of x in here, then we're going to get a positive denominator with a negative there, so it's a negative second derivative, which means it's concave down over its entire domain. All right. More review properties here from Algebra 2 and Pre-Cal. All right, we're going to use these properties quite a bit to make taking the derivative of complicated natural log functions a lot easier. So those are going to come in handy a lot. So it's good for us to practice using those properties, and there's just a few examples here of how to expand these. So this one, we have the natural log of 15 over 4. We can expand that to the natural log of 15 minus the natural log of 4. Here I could expand this. Well, I could start by rewriting this as natural log of 2x minus 5 to the 1/2, and then I can bring that 1/2 in front as the coefficient of natural log. I can write it that way. And this one here, I have x times y squared, and those are divided by a 3, so I could break that up into natural log of x plus natural log of y squared minus natural log of 3, and I could further bring this exponent here in front and make that natural log of 3.